We are preparing to live stream. We have attendees starting to enter the room. Welcome, everybody. It's just going to take us a moment to get up and running here. Okay, that was me being repeated on YouTube. I've now shut down my YouTube window, so that won't happen again. And I've sent out the link, so folks should be joining on YouTube as well. We have 56 people, attendees in the room already. That's great, but we have 175 people registered, so we'll give folks a bit more time to filter in here. Meanwhile, since we have Ray Villard here, why don't you tell us a little bit about the picture you released today? Oh, you're probably going to talk about that during your talk, aren't you?
No, actually, I'm not. I didn't want to show it to you guys before we released it, so it's not in my talk. It was a funny piece of numerology. We were looking for targets. Somebody suggested NGC 2020 because of the year, and I said, oh, that's silly. We're going to pick it because of the year. We're going to do some numerology. And NGC 2020 is the little blue nebula that's a Wolf-Rayet star. Next to it is NGC 2014, which is a huge star-forming region. And so the numbers went out the window. But in terms of an attractive target, the more we looked at it, first we were just going to go look at 2020. Then we said, no, 2014 is really cool. But there's a tremendous dynamic range between the bright stars and the faint nebula. And that bubble, that coral reef bubble structure to it. Picking the exposure times, getting background stars, getting the correct filters. We had people working on that for months, and it was really, there was some guesswork. What combination of exposures and filters? And it's a mosaic, so all that, those different fields have to all get stitched together. And our image processing guy, he's a perfectionist, and he kept worrying about noise in the data. And believe me, you gotta go looking for the noise. It's just a beautiful picture. Maybe if you zoomed up, you'd see a little bit of noise. I was skeptical at first because somebody picked it because of the 2020 thing. But when it all fell together, it was just a beautiful, gorgeous. You can't go wrong with these starbirth nebulae, with all the structures, the elephant trunks, incredible detail. That's ideal for Hubble, and rich colors from the ionized oxygen, nitrogen, and hydrogen. So it really fell together. I'm floored. I didn't imagine it would look that good. Because we're like, oh, I'm gonna look at another nebula. If we look at another nebula, what do we look at? Another galaxy? We look at galaxies all over the place. So what can you do? All the pictures we've done over the years, what can you do that's new and kind of interesting? And this worked out.
Well, I think it's just lovely, and I think you guys did a great job with it today. We're just waiting for folks to filter into the room now. So a few more folks are joining us now. If you've come here looking for the talk on the 30th anniversary of the Hubble, you've come to the right place. If you've come looking for something else, you've come to the wrong place. So, but stick around for a talk on the 30th anniversary of the Hubble. Anyway, why don't we take a moment here to introduce folks so that people can put names to the faces that they're now staring at. I'm Phil Groff. I'm your host. I'm the Executive Director of the Royal Astronomical Society of Canada, and I'm thrilled to be here this evening on this special occasion, the 30th anniversary of the Hubble Space Telescope. I certainly remember its launch, being very excited about that. With me, as always, for these special presentations, I have my wonderful co-host, the amazing managing editor of Sky News Magazine, Alendria Brunez.
Good evening. Thanks for the introduction.
Great. And Alendria is going to handle all the question and answer portion at the end of the evening and put on her reporter hat and ask questions of these guys. And that brings me to, who are these guys over on the other side of the screen here? Well, first of all, a man who should need no introduction to the RASC members who are on the call, but I'll introduce him anyway. Our president, Chris Gainor. Say hello, Chris.
Greetings.
Thank you. So Chris, of course, is our in some ways our premier speaker here tonight, because he's got his book on the 30th anniversary of the Hubble that he's going to be talking about as he talks about this history going forward. But even before that, we have a very special guest with us tonight that Chris was able to arrange, longtime friend of his. 34 years you've spent as the news director at Hubble Institute. Is that correct, Ray?
Yeah, time goes by fast when you're having fun.
Excellent. So Ray Villard is with us.
It's been like living in a science fiction movie.
Okay, I see a few more folks are joining, so we'll let them keep coming in. And meanwhile, I'm going to see if I can let Zoom share my screen. Okay, and hopefully it will do that now, so that I can show that beautiful image we were just talking about a moment ago. And Ray, while folks are still coming into the room, would you spend a moment just telling us what we're looking at here?
Yeah, this is a very rich star-forming region out in the Large Magellanic Cloud. As you know, the LMC is just full. It's undergoing starburst, and it's got these features all over the place. We picked this partly out of numerology. The blue object at the lower left is NGC 2020, and somebody thought, oh, that'd be cute, we'll do 2020. But the big nebula, which is kind of bowl-shaped, you can imagine you're looking to the side of a bowl. That's NGC 2014. First, we were just going to focus on the blue object, and then we figured, maybe that other nebula is pretty too. Let's talk to the director into giving us orbits to do a mosaic. Now, the blue nebula is a very hot star, a Wolf-Rayet star, and it's surrounded by an hourglass outflow, but the hourglass is pointed towards you. So you're looking down the throat of this thing. The emission, the orange, the red nebula, of course, is hydrogen emission. You can look down and see a lot of very extremely bright hot stars. All the stellar winds blow these bubbles that you can see over to the right, and gives it this. Our joke was brain coral structure, which is really kind of intriguing. It's a very faint structure, and we had to adjust the exposures. It was very tricky to adjust the exposures. And we also needed exposures to get the background stars. So this was a very, from the point of exposures and filters, very challenging. But you can go to our HubbleSite.org, you can download the full resolution picture, which is huge. And you can zoom down into the very center where that turquoise structure and the elephant trunks, the little pillars of creation features, all that. It's very rich. And again, we're looking into the side of a bowl-shaped cavity where the stellar winds and the ultraviolet radiation are just eating out everything. And you see this in star-forming regions across the Milky Way, but the Large Magellanic Cloud is ideal for that. It's really got all kinds of crazy stellar fireworks going on. And again, the resolution is so exquisite. I mean, you can find this picture taken by the European Southern Observatory, and not to brag, but this one, yes.
Absolutely. Well,
you just go down and down and down.
Well, for those who've been tuning in now, we're marveling over this wonderful piece of art here, which is the brand new image just released from the Hubble Space Telescope this morning, in honor of their 30th anniversary. And with us, we have Chris Gainor, our president, who's written the book on the Hubble's 30 years, and Ray Villard, who is sharing this picture with us right now and is about to share some memories and some slides So I'm going to stop sharing my picture at this point, and I'm going to toss things over to Ray so that he can talk. But just before I do that, I'm going to point out to folks a couple of features at the bottom of your Zoom screen. You can see a button there labeled chat. And if you press that chat button, it'll bring up a window where you can communicate either with the panelists or with everybody who's present here. And so I encourage you to engage in some of the wonderful conversation that's already started up there. We've heard that Chris is out of focus. I think that's just Chris. I mean, that's but we see some other comments already coming in there. The other thing is there's a button that says Q&A. So if you click on the Q&A button, you can ask a question, and we're going to stack them all up there over the course of the evening, and then Alendri is going to use those to guide her Q&A portion at the end of the talk tonight. But we do have one that's up already. It's from Peter Hutchinson, and it's, while we're waiting, who flies it? I'm not actually
Who
sure what
flies
that means, Peter.
the Hubble telescope?
I assume that's the question, yes.
Well,
let's see.
I'll let Ray answer that.
Well, that's an intriguing question. Early plans for a space telescope called for astronauts to go up and put sheets of film in it. And that idea is gone. It's controlled as a spacecraft at the Goddard Space Flight Center. It's in Greenbelt, Maryland. They have computers all automated now that run the spacecraft. My home base, Space Telescope Institute, runs it as an observatory. We take in proposals from astronomers around the world. Committees select the best and cleverest proposals. It's a huge competition. It's about a 10-to-1 competition for those who get time and those who want to get time. And then our people do, it's one-stop shopping. We do the planning and scheduling of the observation. We have a huge archive for future generations, the Mikulski, it's called the Mikulski Archive for space telescopes.
The space telescopes, MAST.
MAST, yeah. And that has data from a lot of other NASA missions. But we're getting more and more news out from things that people find in the archive that they didn't think about when the exposure was taken. You can find other things. So that archive, even if Hubble stopped working tomorrow, that archive would keep astronomers in business for a very long time.
It's just fantastic. So at this point, I'm just going to ask Chris to take over the screen, bring up the slides that you brought with you, Ray, and you can take it away. And thank you again for being here. Ladies and gentlemen.
I'm delighted. I've been up to Vancouver a lot of times. I love talking to you folks. I feel like a celebrity up there. I come back to Baltimore and I'm one of the hired hands.
So yes, I'd just like to introduce my friend Ray Villard. One of the great benefits of RASC membership that we don't often talk about is that we get to meet some incredible people. And after I joined the Vancouver Center in the early 90s, very shortly after that, Ray came up to Vancouver to speak to us about Hubble. And I met him for the first time. And little did I know that we would be interacting quite a bit over the years. I was able to visit the Space Telescope Institute back then. And then more recently, when I've been working on my book, which is going to be published later this year on Hubble. So I'm just going to hand it over to Ray. We've got his slides up, and so it's all yours, Ray.
Okay, thank you, Chris. Yeah, I've known Chris for a long time. I think my first trip to Vancouver was in '94, right
That's
after
right.
the servicing mission, and I had a fantastic time up there. And I've been back every few years. And again, everybody up there, you guys are incredible hosts. I feel like Vancouver is a second city. Anyway, what I wanted to do was, in about 15 minutes, give you an overview of why is Hubble so unique, why is it so special, why has it gotten this celebrity status. And I think my key theme is it was a perfect storm of a lot of crazy stuff that came together. And I'm going to go through that. Where else can you find a cartoon like this one? Can't we get a Hubble? Next slide, please. Or for you amateur astronomers, a cartoon like the next slide. You see that in somebody's backyard. And in the next slide, you can find Hubble everywhere. You can find the Space Telescope on the side of a U-Haul bus, the photographs used in advertising. There were billboards on Times Square. It's on coffee mugs, T-shirts, neckerchiefs. Again, it's a cultural phenomenon. And the most amazing thing to me is that it's known on a one-name basis. You don't even have to say Space Telescope. You say Hubble. We've become synonymous with astronomy. And I want to explain why. Next. You can even, this I thought was kind of interesting, you can buy contact lenses called Hubble. That's how common the name is. Next. We've got a lot of headlines. One of my favorites is that we photographed heaven. Finding the right ascension and declination for heaven was kind of tricky. But what I thought was interesting was that we go across religious groups love. They find, and this was a calendar, biblical words of inspiration. And again, the pictures transcend the science. They are so evocative, and some people find them spiritual. Next. Not more than clouds of gas and dust. We've had cameos in several Hollywood movies. The one that I really liked was Independence Day 2 that came out a few years ago. And this is from the script. And the general goes, this picture just came from Hubble. They're pulling on Saturn's rings. But I loved it because he didn't have to say, this picture came from NASA's Hubble Space Telescope. This came from. So even in a movie script, we're known by one word. Next. Which I thought was fun. So people ask me, how did you guys orchestrate this tremendous public affairs program to make Hubble a household word? And the honest truth is there was no grand organization. There was just a passion and dedication to communicating astronomy with me and my people, and also the astronomers we deal with. So I call it the Indiana Jones approach. We just made it up as we went along. Next. So why Hubble? Hubble plays out, I'm going to come back to this, it plays out like a movie drama. The anticipation of launch, the optical failure, the redemption from the servicing mission, the adventure of looking across the universe. Then we had to deal with another cancellation in the mid-2000s. We survived that. There was more drama, and then we got fixed, and we got our final servicing was 2009. That's going to keep us going well into the 2020s. Next. And I thought this was a nice tribute from John Logston. We've done a wonderful job of branding, identifying Hubble with frontiers of knowledge and discovery, which has made Hubble iconic, and even people dress up like the telescope. Who does that? Next. Oh, hit it one more time, Chris. Oh, this was launched. I just show this to show that the mission has hardly aged me. I'm second from the left. That's when I had hair. But this was 30 years ago. The picture's killing me. Anyway, next. With the few astronomers, Eric Chasen, by the way. I'll talk about that. When Hubble was launched, Timothy Ferris, very famous science writer, said, besides its complexity, it says more about us and the better we can know. And I thought that was very poetic back in 1990. Next. Now, the funny thing is that there was a fight, which I think Chris will talk about. I think it was in the Eric Chasen book too. Astronomers are a little worried about the first pictures from Hubble. For example, they were worried, this is a picture taken much later, but it's a globular cluster. And they were worried if we did pretty pictures like this after Hubble was launched, you might give away brand new science because nobody saw the core of a globular cluster in that kind of detail. This is what we imagined the early release pictures from Hubble would be. But that program was killed out of almost a paranoia that you were going to give away the goods if you put out pictures that were too good. That's ironic because it went in the opposite direction. Next. So this was the first picture from Hubble. NASA was cornered into releasing the very first thing that we looked at. It's a few stars in an open star cluster. And media were nice. They said, oh, you know, Hubble's doing better than ground. You see the ground based on the left, but you know, and you can, the little tentacles are spherical aberration, but we figured that out a few weeks later. Next. So when the aberration was discovered, that's when I had the world's best crummy job, according to an article in the Toronto Globe and Mail, because I was the PR guy, and we had to live with being the brunt of all kinds of jokes and from late night comics. The biggest understatement of my career is in this article from the New York Times. They called me and said, what's the Institute's position? And I said, well, obviously we're not pleased. Forget it, that was the biggest understatement. Next, hit that one more time, Chris. So this is what we had to live with. And I can laugh now. We weren't laughing back then. Next. And we, again, got cameos in movies. We were destroyed in Mystery Science Theater. And in the movie Naked Gun 2.5, you see on the back wall is a picture of the Edsel, which was a flop, and a picture of Hubble, because they were making fun of it. And the folks at NASA just about jumped off the roof. They were so crushed by this, by all this making fun of Hubble. Next. And so for, you know, for all your amateurs, here's the thing. This was a picture of, on the left, picture of a star with a comparable size mirror on the ground, of course, without adaptive optics. And then here's the picture when Hubble, the mirror with the misshapen mirror, the spherical aberration. And you can see a lot of the light is lost in the skirt because it's out of focus. And then when we fixed Hubble in 1993, you can see all that light is concentrated into a dot. Next. But even when we were broken, we still took some great pictures. These were just a few months after the aberration was announced. A beautiful color picture of Jupiter, a beautiful color picture looking into Orion, which is nothing compared to the new color pictures of Orion, and a beautiful picture of the ring around supernova 1987A, which in fact we hand colored because we weren't ready to do colored pictures yet. So I didn't go along with that, but that's a hand colored picture. The pink was hydrogen, the yellow was sulfur, and then there were background stars. The picture of Jupiter kept coming out of the photo lab green. And I said, wait a minute, amateurs are going to laugh at us because you look at Jupiter through a telescope and you know the white clouds. And then the PI on that camera said, oh, Ray, make it whatever color you want. I'm colorblind. So we fixed that. Next. So of course the optical fix, the contact lenses were made for Hubble in a deployable optical bench that was installed in December 1993. A brand new camera with corrective optics was put out during the mission, and our beloved Senator Robert Mikulski from Maryland held up the seminal picture of blurry versus sharp, and then we really turned the corner on that. Next. So it was all fun and games after that. And again, Hubble really became a cultural, what has really driven Hubble has been the astronaut spacewalks and servicing mission to Hubble. You've got big science matched with the glamour and challenge of space. Here, the whole crew of the first servicing mission appeared on a program called Tool Time from the early 1990s, showing these very expensive tools that they used to repair Hubble. Next. So a big part of Hubble's success is the drama of the 5 servicing missions that keep upgrading the telescope. And so today Hubble is in better shape in terms of the instruments. It's in better shape than it was when it was launched. The only thing is that we're down to 3 gyroscopes, but those were installed in 2009. We think those are going to last us through the 2020s. And then I think in 1997 or 99, we put a new computer into Hubble. It had some old magnetic core computer. We put a new computer for you computer nerds built on the Intel 486. I think that was the chip.
That's right. It's a blazing 486.
Yeah, but Hubble doesn't do Windows and it doesn't do the internet, so it's fine. Next. Oh, and then each mission gave us wonderful front pages of cool pictures. The big drama was the last one. That was back in 2009. And I think, Chris, you remember this. The bolt got stuck. They were putting in a fantastic camera, wide-field camera 3, where that gorgeous picture you saw today came from. But the bolt got stuck. And my blood pressure, my blood pulse rate went up to 120. That was the scariest moment for me. And not just me, you can see the project scientist from Goddard, Dave Leckrone. Anyway, the bolt came loose, but the picture on the right, though, I love. This is straight out of Hollywood. You have a rescue shuttle. You've got the Atlantis streaking out of Kennedy, and there's a rescue shuttle, of course, because this is after the Columbia accident, and there was a fear the shuttle would be damaged on launch. So they were ready to launch a rescue shuttle. And again, that's straight out of some Hollywood movie idea. That was just nuts. Next. So I can't get into all the discoveries. That's an hour-long talk. But I do want to make the point. The blue balloons are what Hubble was sold to Congress for. If you give us $1.5 billion, we'll refine the cosmic distance scale. We'll peruse other galaxies, and so on and so on. But the orange balloons, which has kept my job so exciting, are things we did not expect. Everything from dark energy to planets around other stars to the abundance of black holes. And that picture of me and my colleagues back at launch, none of us could have imagined the incredible new universe with all these orange balloons here, all the discoveries that nobody had even thought about. Next. But Hubble's, what has made Hubble famous has been the imagery. And I found this quote from a nature photographer. It reaches, it inspires people with awe, and the idea we're seeking to understand it all. And again, it hits people at a very visceral level, an emotional level. And especially, the iconic pillars of creation, which to this day remain the most seminal picture from Hubble. It has reached people at a whole level, philosophical level, beyond the nitty-gritty science. Next. And why were the pictures so great? And this goes back, I know when I was a kid, you could, in fact, this was a book I had as a kid. There were maybe, my recollection was there were maybe 24 black and white pictures, a lot from Palomar Observatory. And they were gorgeous. I found them evocative. They were mostly black and white, and there weren't many of them. And you had to go to the library or buy a book to look at these pictures. Next. But with Hubble, the beauty with Hubble is that we came on the cusp of the internet, and we could assemble incredible pictures, and we could distribute them to everybody across the internet. And people could download them. They could make screensavers. They could put them on coffee mugs. It was the democratization of space astronomy. We had a flood of pictures. They were very dramatic pictures. Each picture told a story. And again, the nicest credit for this is from the New York Times, saying that our pictures are as important as the Apollo Earthrise picture. That is seminal. But as a PR guy, what really tickled my heart was the New York Times said, this has been done at a reasonable price. The Americans, a lot of Americans feel that the space program blows too much money. And even before launch, people said, oh, is Hubble worth 1.5 billion? Nobody questions the cost of the Hubble. It is considered a bargain for I think the run-out costs are probably 13 or 14 billion, but it has given us the universe, and you really can't put a price tag on that. Next. Of course, run-out's about as long as we last. And the New York Times captured the essence of these pictures, which is one of my other favorite quotes. Hubble finds a new frontier, a different universe. And that's one of the key things. We unveiled, with our tremendous power, we unveiled a new universe, a discordant universe with cataclysmic disturbances and things seen in astonishing clarity. It was the undiscovered frontier. And I think that's Hubble's biggest legacy. Next. And this came, well, the picture we put out today, and this picture of the Carina Nebula, you know, we work very hard to balance objective and subjective elements of the image to capture the essence of celestial objects. And that's very important. People say, well, gee, would it really look like that? Well, as you all know, if you flew out there, you wouldn't see anything. It would all be gray because it would be scattered all over the sky. And so I keep telling people, don't ask what it would really look like. That's a meaningless question. As with today's picture, we work very hard to capture, and color especially, to capture a beautiful picture also contains a lot of scientific information. So I repeat myself endlessly about this. These pictures capture the essence of celestial objects. Next. And this was a nice quote from Kathy Sullivan, who was on the first mission 30 years ago. And she says, you know, I can't remember any instrument entering into popular conversation the degree to which the rich and artistic understanding of our universe through these gorgeous and exciting discoveries, of course, like dark energy, but it's really the pictures that are Hubble's forte. Next. And this, I've never met this guy, but I love him. His quote in an article, the power of human reasoning, along with boundless creativity and human curiosity. Next. And he went on to say that all 20th century philosophy exists in the wake of the Hubble telescope. That's pretty lofty, and I love that idea. And maybe that might sound like hype, but I didn't write it. This gentleman wrote it, and I think it's cool. And maybe the last slide. Let's see what the next one is. Am I at the end, Chris? Oh, no. Okay, so this is why Hubble is iconic. If I could write a movie script, the anticipation of Hubble as the amazing time machine, and then it falls from grace as a billion-dollar bundle, but then it makes a comeback. And that's in all of Hollywood stories, you know, the rise and fall and the resurrection. And then from the mid-90s into the 2000s, we just gobble up the universe. We really gobble up the universe out too, within a few 100 million years of the Big Bang. We have another drama in the mid-2000s when the fifth servicing mission was canceled, but there was such a big public pushback and outcry about this. NASA really felt they had to reinstate that mission. So we get fixed up, and again, we're redeemed again. And we are looking forward to some very intriguing science in the coming years. Hubble, we think, will certainly be in excellent shape well through the mid-2020s and beyond. And so, you know, as far as I'm concerned, as much as we've done, maybe the best is yet to come with some of these discoveries and pretty pictures. And that's it.
Well, thank you very much there, Ray. I know you've given us a lot to think about, a lot to ponder, some beautiful images to once again remember and to contemplate. I know that Chris is itching to go here. He's got his talk. So I remind everybody, you've got questions for Ray, put them in the Q&A tab, and we'll let them get asked at the end of the session. And in the meantime, we're going to hand things over to Christopher Gainor, who's going to talk about his book and his view of 30 years of the Hubble Space Telescope.
Okay, my slide, you can see my slide there clearly. I apologize for the picture of me. It's just, I've got a crappy camera and I can't run out and replace it because of you know what. This book cover you see here is the book I've been working on for about 5 years, and NASA is going to be, the NASA History Office is going to be publishing it later this year. I'm just right in the middle right now of looking at the galleys and going through production things, and I decided to celebrate today's anniversary by releasing the photo we have for the cover of the book. And the title "Not Yet Imagined," of course, comes from something that Ray was talking about, which was that a lot of the discoveries we didn't expect and we didn't imagine them. And also some of the twists and turns in the Hubble story, it's the same story. No one imagined that the mirror was going to be have the problem it did. And then you know, some of the other aspects of the Hubble story, it's been quite amazing. And it's been a really great privilege to be working on this the last few years. Well, I will be announcing it when the book comes out at the end of the summer this fall. It will be available as a book. It will also be available as a free download because it is a government document put out by NASA. So, so you have a couple of options there that one of which you might not have anticipated. And I'm a historian, and I'm just going to run through some of the history. Ray has already run through a lot of it, but that's fine. And of course, the telescope is named after this fellow, Edwin Hubble. And in a few months, we're going to be coming up on the 100th anniversary of Hubble's big discovery. And just to boil the story down, there's all sorts of subtleties and to the story, but basically, Hubble was the astronomer who really firmed up the discovery that our universe is much bigger than the Milky Way galaxy we lived in. 100 years ago, there was controversy, but a lot of people thought that the universe basically didn't extend much beyond the galaxy we live in. And Hubble found essentially proof that our galaxy was just a very small part of the universe. And just the Hubble telescope was named after him because of his great position in the history of American astronomy, but also because one of the great expectations put on Hubble was that it was going to find out how big our universe is and how far back in time it goes. And it was certainly successful on that score. So there was a number of people whose thinking led to Hubble. Hermann Oberth, the great German-Romanian space theorist, was the first person who talked about, that we know of anyway, of putting a telescope into space. But the fellow on the left, a guy named Lyman Spitzer, who spent most of his career at Princeton, actually wrote the first serious proposal for a space telescope back in 1946. And over the years, he championed the idea of building Hubble. Hubble was not the first telescope put into space. In the 1960s, we started launching things like the Orbiting Astronomical Observatory and various other smaller space telescopes. But Spitzer worked through the rest of his life to get Hubble launched. And as a matter of fact, the day of the launch, he was probably standing not very far from where Ray was that day, and he got to use it himself. He passed away in 1997, I think. And then on the right, we have Nancy Grace Roman, known as the mother of Hubble. She was the first head of astronomy at NASA back in the 1960s, and she did a lot of work around getting Hubble off the ground in the early years, and she lived until just a year or two ago. I remember I bumped into her once at a a conference, and I'm sure Ray knows both of these people quite well. This, I don't think I need to go into much explanation of this slide to this audience, but the idea of Hubble was not only to get it above the atmosphere, which of course stirs up everything we see through our telescopes, unless we have adaptive optics, but it also allows us to look at more various wavelengths of light that we can't see from the ground because they're blocked. Now, Hubble operates mainly in the visible wavelengths and the near infrared and also ultraviolet light, and it works in tandem with some other observatories. These ones here, known as the Great Observatories. Hubble was the first one of these launched. The other ones was the Compton Gamma Ray Observatory at the left, which of course was looking for gamma rays, and then the Chandra X-ray Observatory, observing in the X-ray part of the spectrum. It was launched, I think, in 1999, and it's still going. I think it's it and Hubble are the only ones still going. And then the one at the right, Certif, operates in the infrared, and it's actually was named after Lyman Spitzer, who we saw earlier. And Certif just closed its career in January, and it was observing mainly in the infrared, which we'll talk a little bit about in a moment. This is a schematic of Hubble, and this is important. My book talks about how Hubble was designed to be serviced by astronauts. It has a number of instruments on board. Sort of in the lower left there, you can see the axial instruments. There's 4 of them. And then slightly above that, just under the main mirror, you can see 4 radial instruments, 3 of which are actually optical sensors for the fine guidance of the telescope. And one of the cameras is up there. And then just above it, you see the main mirror and the structure of this telescope, which of course is familiar to all of us. But all those instruments there were designed to be changed out. And over the years, there were a number of instruments that were put on Hubble. There were 5 servicing missions that went to Hubble after Discovery deployed it 30 years ago. And you can see in this chart here the various instruments and when they were on board Hubble. So Hubble today is very, very different from the one that was launched 30 years ago. Its capabilities are much greater today. And you can see the photo at the upper right there is probably, I can't remember, but it's one of the main cameras for Hubble. It's one of the radial instruments, and then below that you can see one of the axial instruments, which kind of look like a phone booth being changed out in one of the servicing missions. And just a quick thing about how Hubble operates. Kind of the engineering control center for Hubble is at the Goddard Space Flight Center in the suburbs of Washington, D.C. And it's about hour drive south of Baltimore, where the Space Telescope Science Institute is and where you would find Ray. And I suppose sometimes that drive is longer than others for various reasons, but the most of the scientific operations for Hubble are run out of STSCI. And you can see that the data, the orders, the commands going up to Hubble and the data coming back are relayed through the tracking data and relay satellite system between Hubble and then to Goddard and then to the Space Telescope Institute. And an interesting thing is that there are 3 places on Earth where you can find all the data from Hubble. One, of course, is at the Institute in Baltimore, and the European Space Agency has a 15% share in Hubble, and so they have their own archive in Spain. And then the third place, I could practically walk to it from where I'm sitting. It would be a few hours. It's about 10 miles from where I am, and it's at the Dominion Astrophysical Observatory in the suburbs of Victoria. And although Canada is not a formal partner in Hubble, the folks at the Canadian Astronomy Data Center were so skilled at archiving data that they were quite involved in setting up the archive for Hubble. So in honor of that, the third set of Hubble data is right here on Vancouver Island. So anyway, this is the event 30 years ago, and Ray was there and talked about it, and then we had this event, which Ray also talked about, and the reasons for it are rather complex, and I get into them in my book. But the mirror was actually the main mirror for Hubble was precisely ground to the wrong shape, and just a fraction of the width of a human hair was the error on it. But and that mirror was actually ground nearly 10 years before Hubble was launched. But it was sort of a whole series of things going wrong, including management and NASA cutting corners. Oh, let's not do this extra test, various things. And it wasn't discovered until about, or at least people didn't really wrap their minds around it for about 2 months after Hubble was launched. And that was a pretty bad time. Hubble became the butt of jokes and all that. And then I'm going to say something nice about Saddam Hussein, because a few weeks after that, he invaded Kuwait, and then everybody forgot about Hubble for a while, except for those people making movies like Naked Gun 2.5. But that was really a great moment for NASA, but also I would say the Space Telescope Institute. Now there was a fellow at NASA called Ed Weiler, who had already got the wheels turning to build a second camera for Hubble that was going to be better than the first one. And that camera was able to be modified to contain, in effect, mirrors that acted like contact lenses. So WIFPIC 2 was being built. But then you had all these other instruments, and the folks at the Space Telescope Institute looked at all sorts of ideas. How do we fix Hubble? How do we fix it? And they finally came up with this idea of putting in an instrument called COSTAR that moved similar mirrors into the light paths of the other instruments. They had to sacrifice one instrument, but they were able to get the other ones operating in full focus. And so in 1993, 3 years later, the first servicing mission to Hubble was launched, and this is this is actually my favorite moment from that servicing mission. They had 5 spacewalks that week, and they changed. They installed CoStar. They installed WIFPIC 2. They had to replace the solar panels because they were causing problems. They were shaking, and this is Kathy Thornton releasing one of the solar wings. They were going to fold it up and bring it to Earth, but they couldn't. So she released it, and you can see the thrusters firing and causing this solar panel to fly away. It looks like kind of a weird prehistoric, flying pterodactyl or something like that. And I thought that was really one of the amazing moments. That mission got a lot of coverage. I remember it was our cable systems back then decided to carry NASA TV. We weren't really at the point where we had high-speed internet yet, so so it was fun to watch that. And Ray showed you this photo here. A few weeks after that mission, this was released to the world, and Senator Mikulski said that the trouble with Hubble is over. And a few months later, we had Shoemaker-Levy 9 and the comet that crashed into Jupiter. We had those great pictures. And Ray tells this story, which is in my book, about how, for a while people were saying the repaired Hubble or the troubled Hubble. And then within 6 months of this, people would just say Hubble. And now a lot of people don't even realize or remember all the problems that Hubble had. So we had 5 servicing missions, and this is another slide that Ray showed, but it's kind of interesting. In working on the book, I explored all these various missions, and each of them has their own story and their own challenges. For example, servicing mission 3 was split into 2 missions because there was so much stuff to do. And there was also the problem of that it was coming up on the end of the century. The gyros were dying, and they had to get a mission up there in a hurry. But some of us will remember right at the end of the century, we had a problem called the Y2K bug. And they did not want to have a shuttle in orbit on December 31st, 1999, or at midnight that night, because people were afraid that everything was going to shut down. And they did get that mission up barely in time, and got the gyros back on Hubble and got it going again. Ray also spoke about the situation with the servicing mission 4, which almost didn't happen. We had the Columbia disaster in 2003, and NASA decided that it was fairly safe to fly shuttle missions to the space station, because if something went wrong with the shuttle, like it happened on that particular Columbia mission, the astronauts could just shelter in the station. But there's no such thing like that in Hubble mission, because Hubble is in quite a different orbit from the space station. And I know those of you who saw that movie Gravity think, oh, well, they had a scene there where people went from the station to Hubble. That really can't be done, because it's the orbits are so different. So there was a lot of concern. Well, if something goes wrong on a servicing mission like what happened to Columbia, those astronauts would be stranded up there, or they would burn up when they came back. And we had that situation that Ray showed, where a rescue mission was sitting on the pad. I think it was going to be called STS-400. and I've got the flight patch for that mission in my in my book, which actually it would be quite a different flight patch from what you usually see. Instead of a shuttle or galaxies or things like that, it had a Saint Bernard dog on it, so a rescue dog. So and then there's just the whole bounty that we've gotten from Hubble, and just zillions of pictures. We just saw the latest one before Ray and I at the start of this presentation that came out today, and this is what 600 images put together by Ray and his friends at the Space Telescope Institute. It's just amazing what Hubble has done in the way of images, looking back to the early years of the universe, but also to some of our closer objects. Most of the planets in the solar system, I think once even a photo of the moon, although that's not really an easy or profitable target, I guess. But a lot of the work done by Hubble is not only photographs or images, it's also spectrographs, which of course are the fingerprints of the objects Hubble is looking at, and a lot of the bread and butter work of Hubble is done that way. Anyway, if you want to look at these at your leisure, these images, just go to the Hubble site, hubblesite.org, and that'll waste a few days of your, or not waste, but exercise it profitably while we're in social distancing. We'll just look at these for a moment. So this is actually a reprise of the Pillars of Creation photo that Ray showed you. I think the first one came out in what, 1995, something like that. And Ray, by the way, was actually one of the people who coined that phrase, Pillars of Creation. Of course, this is M16, the Eagle Nebula. I think a lot of us have looked at it. And for the 25th anniversary, they looked at it with Hubble's newer instruments in a couple of different wavelengths. And these pictures are actually of scientific value because they showed some changes that had taken place in this stellar nursery, which this is, since the original photo was taken. So I'm just going to speak very briefly about Hubble's scientific work. Of course, an important part of what Hubble was doing was to figure out how big the universe is, but also how old the universe is. And I think as a result of work with Hubble and also a lot of instruments on Earth, including the Canada, France, Hawaii telescope, it's been determined that the age of the universe is roughly 13.8 billion years. And a variety of methods have been used to arrive at that figure. including looking at stars like standard candles, which we call Cepheid variables. They're a type of star, and when you look at the amplitude, you can also determine how bright it is, and that's an important step to figuring out how far away it is. When we look at something like, say, a truck or a headlights from a vehicle in distance, we know how big the vehicle is and how bright the lights are, so we can figure out how far away it is. That's not necessarily the case with stars. So we've used things like Cepheid variables, and then for more distant stars, supernovae, to come up with that figure. And that work is still going on. And that's the work with Hubble and other instruments led to the stunning discovery that the universe was expanding, but it was expanding at an accelerating rate. I think 30 years ago, most, not all, but most astronomers would have told you, well, it's expanding, but the rate is decelerating. I've listed a couple of other discoveries. Black holes, supermassive black holes in the center of galaxies. That's a big one. A lot of the, a lot of the discoveries of extrasolar planets started out on Earth, and then with specialized space telescopes such as Kepler. But Hubble has been used to actually image their atmospheres and things like that. And it's also been involved, it's also told us a lot about various things in the solar system, and was used to, for example, help guide the New Horizons spacecraft to Pluto. We could talk about, and I don't know if what Ray would say about this, but I always think that this is the most important image that came from Hubble, and I think this was the Hubble Deep Field. It was just Hubble was pointed towards a very empty part of the universe in somewhere in Ursa Major, and I forget, it was like how long that exposure was, but we're talking about a couple of weeks basically. And then there was controversy that came before that. Some people said it's a huge waste of Hubble's time, you won't find anything. But others said, well, we should take a look. And pretty well every object you see here, except for a couple which have spikes, are galaxies. And then there's one or two stars. And this was certainly a dramatic chapter from Hubble. Now, this image is in the stair step image. This is a stair step image, which for a while was kind of a signature of Hubble. This was this meant that this photo was taken with the Wide Field Planetary Camera 2, which was taken off Hubble a few years ago. And they actually stitched this together from 4 different charge coupled devices, CCDs. But the 4th one, which has a higher definition, is smaller, and they didn't make it bigger to save a few bucks. Anyway, that deep field has led to a whole series of deep fields actually using Hubble and other instruments. And this is, I'm not sure if it's the most recent one, but pretty close to it if it isn't. Now you see streaks in here, and these are actually caused by gravitational lensing, which allows Hubble to look even deeper into the past and earlier, getting us closer to the Big Bang. This is, of course, something that was predicted by by Einstein. So some of these objects we see in this image, we're seeing multiple times because of gravitational lensing. And this slide here shows how far back in time and getting towards the Big Bang we've been able to look. First with ground-based instruments at the top, and then with various images from Hubble, and then of course what we hope to get from the James Webb Telescope when it's launched, in theory next year, but it's possible our friend the COVID virus might have something to say about that. Just very briefly, I'm going to talk about since most of our audience is amateur astronomers, early in Hubble's history, the first director, Riccardo Giacconi, the first director of the Space Telescope Institute, decided, well, the public has helped pay for Hubble, so amateur astronomers should be able to have a shot at Hubble. And so in the early days of Hubble, amateur astronomers were able to bid for time on Hubble. And this slide kind of outlines how it went. Now, a couple of things happened. There's a lot of paperwork, or at least the virtual version of paperwork now that the internet is going. And I think that that kind of discouraged some amateur people from applying. So you can see that there are fewer applications as time went on. But I must say, there was a whole variety of applications. Some of the ideas from amateur astronomers were really first class, and I think Ray would agree with that. He was involved in that program, and unfortunately, he was killed a few years later by another director of the Institute. But amateurs are still involved in it through citizen science projects, such as this project with Andromeda that was run through the Zooniverse. And another thing is that on the Archive for Space Telescopes, you see the website there, that data is open to the general public. You and I are as entitled to that data as the top professionals anywhere. There's a bit of a learning curve in how to use it, but amateurs have processed some data with Hubble. We kind of see processing of data from NASA spacecraft more with their planetary spacecraft, but there is some done by Hubble data done by amateurs. And I think Ray and his folks have released a few images over the years that have had some processing done by non-professionals. So to probe deeper into the past, we have to get a new telescope, and that's going to be JWST. And I'm going to make JWST is much bigger than Hubble. It's going to be much farther away. It's going to be 4 times as far from us as the moon is. And we know that Hubble is only, what, about 300 or 400 miles above the Earth. So JWST is going to have to work, and because it's going to be very difficult, if not impossible, to service the way Hubble was. And it is going to be controlled from the Space Telescope Science Institute, and I know they're already working on that telescope. And another point is that Canada is a partner in JWST. So some of our own sweat-soaked taxpayers' dollars is involved in building JWST. Hopefully, it's going to be launched next year, and we'll get a couple of years of it working in tandem with Hubble. They hope to image the same objects with JWST and also with Hubble, which would be in different wavelengths. So one day, probably in the 1930s sometime, or 2030s, Hubble is going to stop working. NASA is mandated by law to make sure that it re-enters safely, or at least is sent into a higher orbit so that it doesn't crash down. It's as big as a school bus. And so if it did land on land, which it probably wouldn't do, it could do a bit of damage. And people say, well, it's too bad we can't bring it back to Earth. But a lot of the instruments have actually been brought back to Earth by the astronauts from the shuttle. And these are two of them. I took these pictures a couple of years ago when I was in Washington. On the left, you can see the CoStar, the instrument that restored Hubble's sight. Now, as various instruments were put in, they had these kind of corrective lenses built into them, so we didn't need CoStar after a time. And then the one at the right is WIFPIC 2, the Wide Field Planetary Camera 2. Now, you're looking at it and you said, well, that thing looks like it was in Al Capone's basement, not in space. You see all those holes in it. Well, those were all places where it was struck by orbital debris or micrometeoroids. Now, that isn't the impacts were actually much smaller than that, but they were all taken out. Kind of larger holes were put into it so that they could be examined more closely. But that gives you an idea of what things are like in low Earth orbit. You're going to get brained with something if you're not careful. So so anyway, I think I will leave it there and maybe hand over things to Phil and Alendria.
Okay, great. Well, thank you so much, Chris and Ray. We have a good lot of questions here from the audience. I think I'll start with the first question that came in because I think it kind of dovetails quite nicely into what you were just talking about, Chris. But after the James Webb Telescope takes over for the Hubble Space Telescope, will the Hubble be retasked to other assignments? It's basically what's going to happen.
You want to answer that, Ray? I've talked about it a little bit.
Yeah. No, in fact, they'll be looking at the same objects mostly. Now, Webb is infrared. Hubble is ultraviolet through visible to near infrared. So if you put them together, you've got a huge wavelength coverage from the mid-infrared to the UV. So let me give an example. Hubble has characterized extrasolar planets by looking at their atmospheres, and there are certain features you can see in ultraviolet and visible. But Webb can look at molecules down in the infrared. So if you want to see what's going on with the planet, you want the whole range. You want to go from UV down to infrared. So they will be complementary. They will be looking at similar objects.
Okay, thank you. The next one is from Mason. How is it fueled? Such an unlimited energy for a 1990s technology. And that's from Mason.
Nuclear power. No, the solar panels, what is it, about 2,000 watts from the solar panels.
Okay. And it's all solar.
Yeah, it doesn't use thrusters. It uses momentum wheels, and then we have these gyroscopes which kind of tell which way it's pointed and all this. And the gyroscopes are kind of the weak point of Hubble, though, right? Because when they there's 6 of them on board now, 3 of them have conked out, and eventually all of them will probably stop working, and that will be the day when they have to basically say goodbye to Hubble unless something else breaks first.
Mhm.
I just learned today we had better built gyroscopes installed in 2009, and those three are working great. There were 3 that have gone offline. We can run on 1 gyroscope, and that's why our people feel by the mid 2020s we'll be in pretty good shape.
Mhm.
The interesting thing, which Chris brought up, these momentum wheels, you got to dump the momentum, and we actually have big electromagnets called magnetic torquers that grab onto Earth's magnetic field and dump that momentum. Now, James Webb doesn't have that because it's way out there.
Mhm.
So it's going to have to use fuel to dump momentum. And that's a little worrisome. That's a finite quantity. So when it runs out of fuel to do these momentum dumps, then it's going to be in trouble. Although I'm told it has much better gyroscopes than we do, and I'm jealous about that.
And there won't be a way to refuel.
Somebody told me that they're thinking of a way you could refuel.
Okay.
Yeah.
My personal opinion, like the JWST is not designed to be serviced like Hubble was,
Yeah.
but I will bet money that that Frank Ceppolina and some of his pals are sitting around.
Oh, they'd
thinking,
love to. Yeah.
well, yeah.
Okay, I'm gonna ask a question that's not on the list here, and I don't know if it's bad luck or anything, but what do you think will take Hubble out?
Oh, wow. I'd be psychic. Well, it's kind of like, let me think about this. You could have a catastrophic electronic failure. The gyros will be a slow death, but again, we can run on 1 gyro.
Mhm.
I'll tell you though, there was a worry that it was going to get hit with something.
Mhm.
And they debated what to do, and then they felt, well, the orbital debris, and then they said, well, the probability is so low, we're not going to worry about it. When I talk to our operations people, they don't give me any disaster scenarios. They say as long as, it's like, as long as your heart keeps pumping, you're fine. So as long as the electronics don't have, but a lot of the electronics have parallel, there's redundancy, and there are parallel systems, there are backup systems. And I heard just today, the primary systems are working great. So our people are very, very optimistic that it will continue well into the 2020s.
Great.
This reminds me of a great story about the astronauts. There has been talk. Well, when Hubble is done, why don't we bring it back to the Smithsonian? And there was a discussion about this at the astronaut office because part of the debate about having the final servicing mission was you're putting astronauts' lives into danger. And one day at the astronaut office they had a vote, and they said, who here would be willing to put their necks on the line to go and repair Hubble, this being before servicing mission 4, so that it could do more science? And virtually every hand in the room went up. And then they said, how many people would be willing to go and risk their necks so we could bring Hubble back to show it in the Smithsonian? No hands went up. So
Okay, thanks for that. Frank asks, what are the annual operating costs and who pays for it?
it works out to about $100 million a year, which is actually less than what it cost back in the days when they had servicing missions.
Did we lose Ray?
Because there was a whole infrastructure to fix instruments and things like that. But now it's about $100 million a year. That's to do things like run the Space Telescope Institute. There's the controllers at Goddard, and then the communications infrastructure for Hubble.
Okay.
Thanks. And that's paid for by the US taxpayer, and the European Space Agency, so European taxpayers also pay a small share of that. They're kind of in the number that's used is 15%, but I think now it's actually a lot less than that for the Europeans.
And the next question, it looks like Ray has dropped out. I'm hoping he's going to join back, but I'll keep going with you, Chris. What size is Hubble? And can you speak to how maintenance and upgrades are done? And that's from Lynn. And I know that you've spoken a bit about maintenance, but I understand too that there was a Canadian astronaut that was involved in some expeditions.
That's right. That's right. I don't have the numbers for Hubble's size right in front of me. I can tell you the mirror is 94 inches, which is what, 2.4 meters or something like that in diameter, the main mirror. I generally say, you know, Hubble is about the same size as a school bus. So that's how big it is. And you know, Hubble is actually bigger than, say, the telescope is actually bigger than, say, the Dunlap Observatory in Toronto, or the DAO out here in Victoria. They're only about 73, 74 inches, those telescopes. So, and the maintenance was done by the astronauts on 5 servicing missions, which I kind of quickly ran through in my presentations. And there was a lot of work that went into those. The astronauts had to be trained, and instruments had to be developed. Special tools were required, and that was a lot of work and a lot of effort. And I think we might have Ray on the phone there.
Are you back?
Yeah,
Ray?
my internet dropped out, so I went to the phone.
Okay, and
modern technology.
Yeah, you
and
can't
so,
see my lovely face, but you can hear me.
Yeah, well, you're coming through loud and clear. So, so I guess next question.
Next question. Do you have a favorite Hubble image? And this is from Adam.
I'm gonna let Ray answer that.
Yeah, you know, I've been asked that a lot, and I'll tell you a funny story. As Chris showed, the seminal picture is the Hubble deep field. And we have the extreme deep field that goes from UV to near infrared. That is a picture for the history books for decades. So to me, that's the most important picture. But I will tell you, I'll keep it short. In the 2002 mission, we put on the advanced camera for surveys, and we were doing some pretty picture exposures for early release observations. And something happened where one target was overexposed. We looked at it longer than we had planned to. And you can find it online. It's called the Tadpole Galaxy. But, so there's this funny little galaxy that looks like a, you know, it's got this long tail because it's interacting. But I sat in front of the monitor, and there was a sea of galaxies, not as many as Hubble deep field, but a sea of galaxies behind it, doing all kinds of weird things. And I looked at that picture for 10 minutes, and it was an epiphany. And I said, this is the way God intended the universe to be seen. There was the clarity. And of all the pictures, that is the one that just kept my jaw dropped. Now, I will say the pillars of creation, that Ed Weiler at NASA, and of course, Chris knows him, called me and said, we're going to do a press conference about, they're called elephant trunks, these stalagmite features. And I said, oh, come on, you got to be kidding. You're that desperate. We know what these things look like. He says, no, Ray, you got to see the picture. I said, I don't have to see the picture. I know what these things look like. And he goes, no, Ray, you got to see the picture. So he came to my office, and I said, you know, it was another jaw-dropping thing. It was like, holy cow. And again, that's where your imagination, you feel so humbled. You you know, there's a line from the original Planet of the Apes where Charlton Heston says the universe is so vast it crushes a man's ego. And yeah, Hubble has been a very humbling experience with things like M16 and the tadpole.
Okay, I just, so our viewers know, I posted the images in the chat with the extreme deep field and the tadpole galaxy.
I'd just like to say something about the deep field. The deep field came out around 95, and that was the time when everybody was getting the internet and computers like the original Macintosh and things like that. You know, where you could actually look at images on your computer. And I think the first image I ever downloaded from Hubble when it came out was the deep field, and that was true for a lot of people. It was just a great thing of timing. And I have a whole chapter in there in which Ray and his friend Zol LeVay figure prominently, where I talk about the influence of Hubble on astro imaging and also just the public acceptance. You know, Apollo was a great television spectacular. I think Hubble was the first internet spectacular.
Yeah, that really made, that certainly is part of the perfect storm that has made Hubble such an icon.
Okay.
And also, we were very generous about handing out pictures in the old days. I don't know if you remember this, Chris, the Voyager flybys.
Oh, yeah.
You had to stand in line. You had to stand in line to get hard copy prints. At JPL. And I'm like,
that's right.
We're not doing that.
Too. I did that. And so did
you.
you.
I'll say, yes. You know what I mean? And I said, we're not going to do that. Of course, we didn't have the internet then. I said, we're going to give pictures to anybody and everybody. But we were still thinking hard copy.
Yeah. We actually have a question here from somebody that ties into that. And so, does all Hubble imagery go into the public domain? And what is reserved from public consumption and why?
I'll let you answer that.
What's reserved for public consumption?
If anything. So does all Hubble imagery go into the public domain?
Oh, well, except for the spaceships. No, let me explain. No, I do. I do have a funny anecdote. Somebody did ask me if Hubble saw UFOs, and I wrote to them and said yes, but we throw out the pictures. Because these are things that just streak across the exposure, some satellites. No, but seriously, no, the deal with Hubble is that the imagery, in most cases, the imagery is proprietary to the researcher for 1 year. But then it becomes public domain. So there is nothing hidden away in a vault that nobody can ever not look at. At the most, they have to wait a year because the researcher needs time to. But I will tell you, there is a special circumstance. If they get a lot of director's time to look at something, let's say a comet that's doing something weird, that immediately goes public. And we've had a few astronomers get nervous because they did something, but they know it's going to go public and they get nervous about that. But there is a rule that if it is something, if you want to get special time to do something which you think is a breaking kind of discovery, you're not going to sit on it. We're going to make it go public immediately. Anyway, there's no hidden pictures. You can go to the archive. You can all go to the archive. You can take anything out of it. You can try your own image processing. There's a wonderful lady in California, an artist who downloads our stuff, and she gives us competition because she does such a nice job with it. We see these things pop up on APOD, and we're like, oh my God, look what she did. Nope, it's all yours to take.
Great. Next question comes from Swapna. What is the coloring process on the pictures captured by the Hubble?
Oh, I
Ray
have
is
to
the
answer
expert.
that. That's the one question I get all the time. And amateur astronomers, you should know this, right? Because the pictures are taken through different color filters, and this utilizes the full resolution of the CCD. You know, in consumer electronics, the CCD has to split the pixels between red, green, and blue. We don't do that. This is through color filters. And then those pictures are, the corresponding colors are added to those pictures when they come down to Earth. So there's and Hubble has a lot of different filters, some narrow band, some broad band. And so there's an element of artistry in terms of what filters you put together. But my key point is that a beautifully done picture in the style of Ansel Adams, who did these nature photography, a beautifully done picture with the proper dynamic range and a rich spectrum, a rich range of color, is not only aesthetic, but it yields a lot of information. So the wrong question I get all the time is that what it would really look like? And again, you're all amateur astronomers. You know, if you look through a telescope, you're not going to see any colors. It's, you know, it's, your eyes can't detect that. So it's the wrong question. We capture the essence of these celestial objects. And we do that, and Chris knows this because he talked to Mr. LeVay, we do that with a reverence to the object. But it does have footing in reality, in that the filters correspond to the emission of the various elements in the nebulae. The only time we like to apply an arbitrary color is for asteroids and comets. Those are usually broadband monochrome, but the color brings out a little more detail. But everything else, planets, galaxies, nebulae, that has a footing in reality, and we try to be very reverent about that.
Okay, thank you for that. The next question I'm going to ask here, what were the top 3 contributions of Hubble to scientific communities?
Oh, Chris touched on them. I think number 1 is the Hubble Deep Field. Number 2 is helping out with the discovery of dark energy and basically the narrowing the expansion rate of the universe. Oh, and the black holes are very common. Black holes are everywhere. We found the first, we confirmed the first galactic monster black hole in M87. And so we did a census of black holes, and we found a relationship between black hole mass and the mass of the bulge of a galaxy. Those are the 3. Chris, would you throw in anything? Those are the 3 that come to the top of my head.
No, that's what I would say too. Is those 3? But boy, if we get into all the things, it's a very long list, you know.
I mean, in the future, the most exciting thing, which Hubble plays a part of, but it needs JWST, is the characterizing extrasolar planets. But I will tell you the thing that I dream about, which is being considered right now by the National Academy of Sciences, would be the true son of Hubble. This would be a 10, 11, 12 meter segmented optical telescope put out where James Webb is. And that could characterize habitable planets. Now, that mission is in the 2030s or 2040s, but that would be as big a deal as Hubble if that ever gets launched.
This is a question I'm going to kind of pull a few of them together here. So have Hubble's optics ever been damaged by micrometeors or debris? And is that considered a greater risk now with upcoming projects and increasing debris in orbit?
Well, it's interesting. I did say there was one piece of debris they were worried about. Nobody's ever told me they thought the mirror was damaged. We do have a little micrometeorite hole in one of the high gain antennas. But I don't worry about it. There's a telescope at the University of Texas. It's a mirror the size of Hubble. Mm-hmm. And some night watchman went nuts and shot bullets down the telescope barrel. He shot holes in the mirror. Mm-hmm. They still use a telescope.
Huh.
So I think again, there was something they did worry about. Mm-hmm. But it's the only time. Then they used to worry about meteorite streams, and we used to put the back of the telescope in the direction of the meteorite stream, but we don't do that anymore.
Okay. And what new instrumentation has been developed that you'd like to see on Hubble?
Well, I don't know. Let me digress. We're going. They're working on the wide field Hubble. Mm-hmm. And it's called WFIRST, the wide. One of those acronyms, wide field. You know this, Chris. Wide field infrared.
Wide field infrared telescope or something like that.
Yeah. So the mirror is an extra spy mirror from the DoD, and they want to put a wide angle camera, so it could do a huge piece of sky, much bigger than a bit bigger than the full moon, I think. So it's those of you with cameras, it's like Hubble's like the telephoto lens, and this would be like a wide angle lens, and it's the same aperture as Hubble. And it could do tremendous surveys. It could in one exposure, it could cover half of the Andromeda galaxy. So that's being developed for a mid-2020s launch.
All right. Well, thank you. I know we're getting a little bit late here, so I might pass it back to Phil and just say thank you to both of you, Ray and Chris, for this wonderful conversation about one of the most important things that have happened in looking into space in my lifetime. I mean, you were talking about the deep field photos, and I found this picture from my high school locker, and it's got the deep field image in there. So it's been a part of my life. And for those of you who are interested in learning more, I thought I'd also plug Sky News, the March-April edition, which also has Chris Gainor's article about Apollo 13. And the cover here is Hubble. So we've got one of the repairs.
Yeah, actually, you mentioned that there was a Canadian astronaut involved in one of the CERN missions, and that's I forgot to respond to that, but actually that story is in Elizabeth Howell wrote the story in Sky News about Hubble, and the answer to that question is in that article. So there's a plug for Sky News.
Thanks, Chris. And back to you, Phil.
Great. Well, thank you all. It was very informative and inspiring, as Hubble images always are. Great to see the picture from your locker there, Landry. I know that Hubble images on the internet were very much a feature of my early internet prowling back in the day, and we all had Hubble pictures as our desktops and such for a while, and some of us still do. So it's great to learn more about these stories. If you've enjoyed this, I'd like to encourage people to come out to our next speakers session 2 weeks from tonight. We'll have RASC member Heather Laird talking about Canadian women in astronomy. So it'll be 7 o'clock, same time, same place, and you can get the details online at our website. That's just part of all the various activities we're offering right now as part of our sort of COVID-19 content that we're providing for members since they can't go out to large star parties in public right now. There's the Insider's Guide to the Galaxy that happens every Tuesday, and it's a great overview of some basic astronomy and how to use stellarium and key features that astronomers need to learn. We have our self-isolation star parties every other Wednesday night, and weather permitting, we're going to be sort of using those to premiere some stuff from our own robotic telescope going forward. And for those of you who are members of the Society and have the wonderful volume that you receive from us, the Observer's Handbook, but have been too afraid to open it up and take a look inside it because it seems like a very dense tome full of just way too much information. On Mondays, we offer a session called How to Use the Observer's Handbook. So all of this programming free of charge. Please come out. We want to see you. And thanks again for everyone turning up tonight. Thank you to Chris. Thank you to Ray. Thank you to Alendria. And thanks to everyone for coming.
Thank you. A lot of fun. I really enjoyed talking with all of you. Hope to get back to Vancouver sometime.
So do we.
Thanks a lot.
Yeah, really.
Good night, everyone.
Good night.